everyone, my name is Elektra Belle from 10 IPA from Sekolah Mondial, and today we're going to learn about chemistry. Today we're going to learn about iron. So, before we start with the lesson, let's have an overview about what we're going to learn. So, in iron, there is a chemical bonding, and this chemical bonding has two types: ionic bond, and covalent bond. And so ionic bond has two types too, which is binary ionic compounds and ternary ionic compounds. And covalent bond itself also have two types, which is acids and base. So what is an ion? An ion is a positively or negatively charged atom or group of atoms. An ion is formed by the loss or gain of electrons by an atom, so it contains an unequal number of electrons and protons. For example, sodium ion, which is Na, and then magnesium ion, which is Mg, 2+, and chloride ion, which is Cl-, and others more. So, there are two types of ion according to the charge and according to the number of atoms. So, according to the charge, it can be cation or anion. Cation is a positively charged ion, for example Ca2 or calcium, and anion a negatively charged ion. As you can see here from the sign here, this is the charge. This is for calcium, it's positive 2 or 2+, and for this one is 3-. And then according to the number of atoms, there is monoatomic ion and polyatomic ion. For monoatomic ion, from mono itself, it means one, right? So it consists of a single atom. For example, phosphide ion, only one element. And then polyatomic ion, it consists of two or more atoms, since we can see from the word poly here. For example, ammonium ion. So there are two atoms here, right? N and H. Now, Lewis dot symbol. Lewis dot symbol is a symbol of an element with one or more dots representing the valence electrons of the element. For example, the number of atoms of calcium is 20. And so we write the valence electron here, which is 2882. I mean the electronic configuration, which is 2882. And then the valence electron is the last, or the outer shell, which is 2 here. We can write it valence electron or Ve minus here. And so we can put dots or X. I will put dots here. And then this one release because it has two electrons here. And then Se, the number of atoms of Se is 34. And so we write the electronic configuration, which is 2, 18, 18, 6. And then the valence electron is 6, as we can see here, the outer shell is 6, and then we write in the Lewis dot symbol, and it binds because there are 6 valence electron here, right? So it needs 2 more so that it could be stable. Same goes to bromine. The number of atoms of bromine is 83, and so we write the electronic configuration, which is 2, 8, 18, 32, 18, 5, and the valence electron is 5. And so write this, and then it binds because it needs 3 more to be stable. And then octet rule. Octet rule states that for atoms to be stable, they tend to achieve the valence electron of a noble gas, which is equal to 8 or 2. Noble gas here, as we can see from the periodic table, this is the noble gas. Helium, neon, argon, krypton, xenon, and the others. So, Ionic equation. Ionic equation is an expression of the formation of ion by gaining or losing certain number of electrons. For example, here, this is S or sulfur. We write the number of atom of sulfur is 16, and so we write into the electronic configuration, which is 286, and then the valence electron is 6, so we write in the form of Lewis dot symbol, And so for this to be stable, it needs 2 more electrons, right? And so we write like this, plus 2e minus. And so because it gains electrons, so its charge became negative. For aluminium, the number of electrons is 13, and so we write the electron configuration, which is 2a3. The valence electron is 3, and then we write like this, and then it releases the electron, and then if it releases, it is positive charge. So we write it 3 plus like this because it released 3, and then it's positive, right? Then, chemical bonding happens when 2 or more atoms join together in order to become stable, forming a molecule. So, chemical bonding has 2 types, which is firstly an ionic bond. It happens between a metallic and non-metallic ion. So, this is metallic, and this is non-metallic. Now, if covalent bond, it happens between non-metals. So, it happens only in non-metals. For example, C with O, carbon with oxygen becomes carbon dioxide, CO2. It is a covalent bond. Different with Na with Cl. Where's Cl? I think this is Cl. This is Cl. It's not I, sorry, this is Cl. And so Na with Cl, this is metal and non-metallic, so it becomes an ionic bond. For example, here, CO3 is covalent. You can see here, C is here and O is here, so it is non-metallic, right? So it's covalent. And then Mg3 and 2, magnesium is here and nitrogen is here, so it's metal with non-metal. So it is ionic. And then N with H is, this is one is N, this is H. H is also included in non-metallic, only H from this, and so on. Now let's have an example of Lewis law structure for ionic compounds. So firstly, Li and Br, lithium and bromine. So lithium valence electron is 1, and bromine is 1, 2, 3, 4, 5, 6, 7. So in order for bromine to be stable, it needs 1 more, and the valence electron of lithium is 1. So from the table here, periodic table here, this is Li, and this is Br. So it is an ionic bond, right? And so lithium gives 1. Its charge is positive 1. When it gives, it becomes LiBr, or you can just write it in this kind of form. And then Mg and O. So Mg has 2 valence electron, and then oxygen has 6. Yeah, 6. And so for oxygen to be stable, it needs 2 more electrons. So we can say that Mg charge is positive 2 or negative 2, positive 2, and then oxygen is negative 2, and then if they cross multiply like this, like plumbum and oxygen, it becomes Mg2 O2 or O negative 2. And then next is aluminum and nitrogen. So aluminum's valence electron is 3, and the nitrogen's is 1, 2, 3, 4. So for nitrogen to be stable, it needs 3 more electron, right? And so you can say that this is plus 3, and this is, it needs 3 more, so we can write it as negative 3. And we cross multiply, it becomes La3 and negative 3. And then for D, plumbum and oxygen. And then for D, Pb and O. So we can say that Pb's charge is 4 plus, and O is 2 minus. And then if you cross multiply, it becomes Pb 2O4, and then you just divide it with 2 and it becomes PbO2. Next example is NaCl. So Na is +1 and Cl is negative, so if you cross multiply it will always also be NaCl. And then MgBr2, Mg's charge is +2 plus bromine 2, and if you cross multiply it becomes MgBr2. As well as this, you don't mind the number here in front of bromine. And then next also K2S. K's charge is +1 or positive, and then S is -2, and so if you cross multiply it becomes K2S. Same as well goes to Al2O3. Now let's go for the covalent compounds. So in Lewis Belle structure for covalent compounds, these are the types of one. For example, Cl2 here. There are 3 kinds of covalent bond here. There are the single, double, and triple. So you can see here, if single, both atoms share 1 electrons. So one gives 1 and the other one gives also 1 electrons. If double covalent bond, it gives two electrons from each of atom. Then if triple covalent bond, it gives 3 electrons from each atom. Now, there is also a nonpolar covalent compounds. A nonpolar covalent bond is a covalent bond in which the bonding electrons are shared equally between the 2 atoms. In nonpolar covalent bond, distribution of electrical charge is balanced between the 2 atoms. So, nonpolar covalent bond is a covalent bond when you share atoms with the same element. So, for example, H and H, it becomes H2 or hydrogen, and then Cl with Cl becomes Cl2 or chlorine, and then O with O becomes O2, becomes oxygen, and N with N becomes nitrogen. And then there's also a polar covalent compounds. A polar covalent bond exists when atoms with different electronegativities share electrons in a covalent bond. So the elements are different. If nonpolar, the elements are the same. If polar covalent compounds, the elements are different. Next, nomenclature of compounds. So we're going to the naming of a chemical compound. It's already official by an organization of IUPAC. IUPAC stands for International Union of Pure and Applied Chemistry. It is worldwide. So naming ionic compounds. Ionic compounds, as we know earlier, it's compounds made of a metal and a non-metal, right? So, in ionic compounds, there are 2 types. Firstly, the binary ionic compounds, which consists of 2 elements, and then the ternary ionic compounds, which consists 3 or more elements. The rule of binary ionic compounds is that name of the first element, the root word of second element, plus IDE. For example, here, NaCl, sodium chloride. So the name of the first element is sodium, and then the root word of the second element is Cl or chlor, and then plus IDE, so it's chloride. And then magnesium phosphide. The first element is Mg or magnesium, and then the root word of the second element is phos, and phosphate actually, but we can just say phosphide plus IDE, phosphide. Then lithium oxide 2, Li2O, calcium sulfide, Ca+, barium carbide. we can change from the name of the element into the compound. So for example, lithium oxide. So the first element is lithium, and lithium is Li, and then oxide is oxygen, which is oxygen is O2, and then IDE, right? So lithium oxide is Li2O. Same goes to calcium sulfide and barium carbide. And then ternary ion compounds. Cations is this one. This is already standard for ternary ion compounds, so it's already there. So the ternary ionic compounds, which consists of 3 or more elements, has their own guidelines. For A, if in their original number of oxygen atoms, the rule is root word of the first element plus ATE. For example, ClO3 minus negative, it becomes chlorate. So the root word of the first element is chlor, and then plus ATE, which is chloride. So the original number of oxygen atoms is 3, and then if with last one oxygen atom, the rule is root word of the first element plus ITE. So the oxygen minus 1, and then it becomes chloride. And then C, if it lasts 2 oxygen atoms, so the oxygen is only 1, we use hypo plus root word of the first element plus ITE. So ClO minus, it becomes hypochlorite. There is no H here, this is only hypochlorite. And then D, if with 1 more oxygen atoms, we use per plus root word of the first element plus ATE. So for example, this ClO4 minus, it becomes perchloride. And these are the other examples of ternary ionic compounds. Now, we're going to name a covalent compounds. So, it has Greek prefixes depending on the number of atoms. So here 1 is mono, 2 D, 3 tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, 11 deca, 12 andeca, 13 trideca, 14 tetradeca, 15 pentadeca, and so on until 20 icas, and so on. And the guidelines for naming covalent compounds: for number 1, use appropriate Greek prefix to represent number of atoms per element in the chemical formula. 2, avoid using mono for the first element with single atom. 3, for oxygen, omit letter O or A for the equivalent Greek prefix to be used. And 4, for the second element, use root word plus IDE. Now, covalent compounds has 2 types, which is acids and base. And now we're going to the acids first. Acid is a covalent compound which produces hydrogen ion or H+ when dissolved in water. So to identify acid, we can use indicators such as litmus paper. So when you put acid, like how to identify acid in a litmus paper, if it turns from blue to red, it means it is acid. If it's red to blue, it means it is base. So the pH of acids is lesser than 7, which is from 1 to 6. If 7, it is neutral, like water. So acids, we can name binary acids and ternary acid. So in gaseous form, the rule is hydrogen plus the root word of the second element plus IDE. For example, hydrogen chloride, this is H, right? Hydrogen plus the root word of the second element, which is chlor, plus IDE, so chloride. And then H2S, which is H hydrogen plus the root word of the second element is from sulfur plus IDE, so it is sulfide. So hydrogen sulfide. If it's in the diluted form, the rule is hydro plus root word of the second element plus IC plus acid. For example, HCl in aqueous form or diluted form, hydro plus the root word of the second element, which is Cl or chlor, plus IC, so chloric, plus acid, so hydrochloric acid. And then H2S, hydrogen sulfuric acid. And then naming ternary acid or oxyacid. Rule 1. if an original number of O atoms, so it is root word of the second element plus IC plus acid. For example, HClO3 chloric acid. And then rule 2, if it lasts one oxygen, you use the rule is root word of the second element plus O's plus acid. So HClO2 minus is chlorous acid. And then for rule 3, if it lasts two oxygen atoms, we use hypo plus root word of the second element plus O's plus acid. For example, here HClO hypochlorous acid. Then rule 4, if with one or more oxygen atom, we use per plus the root word of the second element plus IC plus acid. So HClO4 is perchloric acid. This C is only one. Okay. Now going on to base. A base is a compound which produces hydrogen ion or OH minus when dissolved in water, and it reacts with acids to form salts. It promotes certain chemical reactions or base catalysts, and the pH of base is above 7. So the rule of naming a base is only name of the first element plus hydroxide. For example here. So you can actually differentiate base and acid. Base and acid. If base, we use OH. If acid, it's only H. H in the front. So for example, for base, CaOH2, name of the first element is calcium, OH, and hydroxide. Then PbOH4, lead for hydroxide or plumbic hydroxide. Then AlOH3, aluminum hydroxide. So before we end today's lesson, we're going to end it. We're going to close it with a quote. It says like this: Chemistry says that the more energy you put into a bond, the harder it is to break. From Anonymous. It's kind of related to life, isn't it? So yeah, that is it for today's lesson. I hope you understand what I have been trying to explain earlier. And thank you so much for watching. Don't forget to like, subscribe, and comment. Thank you.